Okay, welcome to everyone. My name is Larry Anderson, November 5 Oscar. I'm located in Tupelo, Mississippi, and serve as the president of the Deep Dixie Contest Club. And we want to welcome all participants to this session of our Zoom learning series. And I think we're going to have a really great program tonight. I would like to call attention to the tremendous number of clubs represented by members who have attended in the past, and we really appreciate your having attended. If you are in a club and your logo is not up here, and we'd like to just have that to celebrate your participation and let us know. You can send me an email on that. Anyway, so we're going to clip right along here, and I just want to make sure that you feel welcomed, because we do welcome you. Just a couple of announcements. The contests, I guess, that are probably on the horizon for most of us are this weekend is the 160-meter contest. Good luck to all of you who do that. I hope you make a lot of QSOs in the heat of the day. And it's also the FT roundup. It'll be FT8, FT4. There's several other contests on, like ready sprints and things like that, but I think these are the big ones. So since most of you all are contesters, I'm sure you're keeping up with that through your own clubs and WA7B&M. The Deep Dixie Contest Club keeps a list of, we actually have a Google sheet showing the ideas that many of our club members have come up with on, what you would like to know. And so there's some really good ideas. I also want to thank those of you who are sending me ideas. You see my email address up on the screen, top right, nn50larry@gmail.com. So feel free to send me your ideas for that. Our next Zoom presentation, if it follows a pattern, probably will be in 2 weeks, which would be December 17th. But we have several ideas that are in the hopper that are just about ready to come out of the frying pan and hit the fire. So we will just watch the email blasts, and I hope you're okay with that. We'd like to encourage you to, if you have to miss any of this session, to go to our YouTube channel, the Deep Dixie Contest Club. You can either just go to YouTube and do a search for Deep Dixie Contest Club, or I tried to give a shortened URL so that you could just go to tinyurl.com/DDCC. That's Deep Dixie Contest Club YouTube. And then that will take you to this page. And you can see some of the ones we posted up there, getting to be a really good set of presentations up there, and we will continue to add those each couple of weeks. We are thrilled to have our speaker tonight, the returning speaker by popular demand. It's Kevan Nason, November 4XL Lima, and let Kevan tell about himself. After a while, it's been a genuine pleasure to have a friendship with Kevan, and he is so good about sharing with us information. And so far, among the videos on our YouTube page, Kevan's presentation on vertical antennas is the most popular, at least the most watched. And based on Google Analytics, the amount of time people spend in a video, Kevan's time is right there on top. So everybody sit up straight in your chairs, get your notebooks ready, and we're ready to go, because here's Kevan. And take it away, Kevan. Go ahead and share your screen and let her rip, Tater Chip.
Everything going, then. I appreciate the opportunity to come here and once again present to the group. Definitely appreciate that. Takeoff angles, as I said in the beginning of this thing. Oh, I need to introduce myself, Larry said. I've been a ham for 40-some years. Didn't get into contest until about my 25-year point. And that's when I think I finally began to learn a little bit about ham radio and what it's all about. I didn't have an Elmer to teach me. I kind of went around by myself in a 20-year Navy career. And it wasn't until I joined the contest community that things started picking up for me. And in fact, that was one of the introductory comments I was going to make about this, was that I think there are basically 4 types of contesters. There's people in contests that aren't there to contest. They didn't go ahead and make some DX contacts or worked all states. Then you got those casual contesters, which I think kind of like field day people who are just trying to kill a few hours and play on the radio in the afternoon. Then you got serious contesters. They can get a little bit of the bug from being casual and decide that, hey, there's a little bit of fun to this. I kind of enjoy it a bit. Let's start figuring out how I can improve. And then you got them competitive contesters, which they think they got a shot at winning and really push to learn every single thing they can. And this particular topic, HFTA, was my transition from a casual contester to a serious contester. And I didn't realize it at the time, but that's kind of like the addiction phase of it, where I stepped off the deep end and started down that slippery path that I've been led down today, and it's become consuming for me in all my ham radio activities. But one day when I was just kind of piddling around, I'd usually do 3 or 4 hours in a contest. I started looking up there and said, you know, I've got an okay station. I've been a ham for 25 years and I've been contesting for a few. How come I'm only getting 200,000 or 300,000 in these contests? And there's these people getting 4, 8, $1.5 million points. What are they doing that I'm not? And I didn't know much about takeoff angles or anything. And I said, I've got to figure out what they're doing that is getting them all them points. And poor old me here is just kind of piddling along. So I decided I was going to start studying things, and went on the contesting reflector and looked around a little bit. And one of the topics that seemed to be coming along over and over and over was this thing about takeoff angles. I had a vague idea, and I decided there's got to be more to this if all the people that are getting good scores and that I respect are talking about it. So I said, I'm going to learn about takeoff angles. And when I started getting into it a little bit, they had that program out back then called Yagi Terrain, done by Dean Straw, N6BV. And it seemed that YT, Yagi Terrain, had just kind of fallen by the wayside. And I ran across a comment by Dean, said that he didn't have accurate enough information to take YT any further, that he needed some more resolution to the terrain profiles that he was able to get. And he says because he couldn't get high enough resolution, YT was pretty much at a standstill. Well, I've been rambling around on the internet, and I ran across this program called MicroDem, done by a guy named Dr. Peter Guth. And Dr. Guth had gotten hold of a source from the National Geographic, not National Geographic, but the U.S. Geographical Society. And they had changed, and Dean wasn't aware of it, and had made these high resolution terrain profiles available. And Dr. Guth was using them in this program called MicroDem. So while I was trying to figure out what all this takeoff angle stuff was and how to use YT and figure out how high my antenna had to be, I contacted Dean and let him know about that. He talked me into writing an article for, ended up in an ARL antenna compendium. I was in S4T at the time, about MicroDem and all. And he got jump started. He got in touch with Dr. Guth and found out about all these terrain profile things. And that's how HFTA came about, rejuvenated his interest in it. So if I've done anything good for ham radio, it's to get him to start looking at this and develop this wonderful program with HFTA. And what it basically does is most of us know about takeoff angles, but the terrain around you for up like 10,000 feet out away from your shack has a significant effect on the radio signal that comes off from your station. And if you haven't looked at this stuff before, that might surprise you. We're going to take a look at a couple of graphs as we go through it. So that's how I got into this a little bit, figuring out if I needed a 50 or 70 foot tower or something else a little bit different. And I started down this path. So why use HFTA? Several questions come into play, things you might be able to use this for. How high should your antenna be? We're spending a lot more money for a taller tower. I got a 30-foot tall tower. Is adding another 10 or even 20 feet worth of that extra work? I'm about to buy a house. It's in good location for, is it in a good location for HF radio? You know, back when this stuff was out, YT and HFTA back then first started coming out, there was a lot of people thought it was just a bunch of hoodoo magic and just another propagation tool. But this thing is now so well respected that people actually are looking at their house location and plotting the data in HFTA to figure out if it's a good enough place for HF, and they're not buying their house if it doesn't meet that requirement. So a lot of people trust this thing. And another interesting thing, Bob and I got the same antenna at the same height. We both run 100 watts. He lives 3 miles from me and works Japan all the time, but I can't. Why? Would moving my antenna help? So if you ever ask yourself those kind of questions, HFTA might be something to take a look at. Use the ERL antenna book quite a bit for different things. There's operating instructions for HFTA. When I wrote this version 104, I don't know if he's changed it or not, but if you read those little instructions that accompany the program that nobody ever really reads, there's a few interesting things in there, and we'll talk about them later on in the end. And we got a couple 3D things to take a look at, some other stuff to take a look at. The actual program HFTA, if we've got time at the end of the hour, we'll run a couple of things and show you how easy it is. We'll talk about some of the things that have happened since Dean wrote it. Some other people are getting some interesting uses out of HFTA for 360-degree angles and things. A lot of people think the decibel's a hard concept, or they don't really know what's going on about it. So I want to take a minute and make sure everybody's up to speed here. And decibel, in the case we're looking at, is really just kind of a measure of power. It's a way to easily compare things. And if you double power, like going from 100 to 200 watts, doubling power is 3 dB. By the same token, halving power is putting it in half is minus 3 dB. So anyway, let me back up again. This is what everybody's used to kind of seeing. You got this lobe coming up here in that direction. But the minus 3 dB curve here is what they call the half power points for this thing. And there we go. If you look at this thing, keep in mind that actually that's the minus 3B is like going from 200 down to 100 watts. So a lobe, we're used to thinking about is going in a direction like this is due north. But a lobe actually goes in a couple of different directions too. We have these things called takeoff angles, which is from where the transmitter is. We're looking at the angle between the radio wave going off and the earth. And this is a very low or shallow takeoff angle. It tends to go a little bit further. The higher angle ones going up, and they do a little bit shorter hops. So that's what we're referring to takeoff angles, and arrival angles. They're pretty well reciprocal as they come in like that. And different distances, different points on the earth are going to have different takeoff and arrival angles.
Here we go again.
Sounds like you may be having a connection issue.
We're not seeing your screen right now. We could hear your audio, but not seeing your screen.
What is going on? I've given 2 presentations, Zoom, since getting this new internet without a problem. So I don't quite understand.
In the Army, we said Murphy and 1-arm push-ups.
Are you seeing the screen now?
Yes.
Okay, so this is a 5-element Yagi. Hopefully this will stop doing whatever the heck it's doing. 5-element Yagi, and it's showing the lobe strength. This is your main lobe, and then as it goes up, you go ahead and see some different changes to it. So the Yagi pattern isn't just a straight one particular lobe. And this is looking at the back part of it over here. There's all these different lobes coming up. And these lobes hopefully line up with the takeoff angles coming in, so you get the strongest energy coming in. Not only you have a directional lobe, this is actually a 2-meter ground planed antenna, but as the height goes up, you also see the lobe changing as well. And when this started out, it was at about 0.6 dB. So while you're watching these lobes changes, also look at, you see a dBi gain change too. So particularly new hams don't quite realize that the height of the antenna affects both the gain and the takeoff angles associated with the antenna. And a lot of times, I did for the longest time, tend to think that there isn't any reason why an antenna at 30 feet shouldn't operate almost as well as an antenna at 60 feet. So more experienced people know that's not quite the case. Gonna let this run its course, be about another minute or so. It's kind of interesting to watch. I put it down a little bit. But if you're not getting your proper response out of your antenna that you think you might, then exploring the antenna height is a good way to look at it. And as it goes up and down, things change. So that's pretty much what we're looking at for two different things. You got multiple lobes, and as you raise the antenna up and down, you change the angles that those lobes are going out at. This comes out of N4XL's book, and it talks a little bit about the arrival and takeoff angles. There's other sources for it. I just chose this one because it's simple. And if you look at the case for the USA to the East Coast, most of the time going into Europe, things are arriving at a 1 to 38 degree angle, with this thing in parentheses being 6 the most common. And this is for a 40 and 80 meter path. Of course, there are all kinds of variances, and we'll see some of them later. Going to Oceania from here, it's extremely low angle, like a 1 degree. And the same as South Asia. I have a heck of a time getting into Oceania and South Asia, and that's why, because of the extremely low takeoff angles. But these charts are out there to tell you a little bit about what the takeoff angles are too. Dean Straw come up with this great tool. A lot of people are familiar with this. It comes out of the ARL tech manual, or not tech manual, but the antenna books. And it shows, in this case, 80 meter heights for a dipole. 1/8 wavelength high is 33 feet, 66 foot is a quarter wavelength, etc. And this shows the gain at the particular takeoff angle. And you can see as it goes up in height that these lobes start coming down. Most US comes in about this range. Most DX is a much lower angle range. And that's kind of important as we go along. If you zoom in at this a little bit more, and what Dean did to come up with some of his charts is he actually flipped this on its side. And now what you're getting is a graph which shows the takeoff angle right here. And then we can start plotting the gain at a particular takeoff angle on a chart that looks something like this. So here you got your takeoff angle, 0 to 25, and the gain coming up along those directions. And if you go ahead and you put that in there, here are some of the lobes and the gain that occurs at every particular takeoff angle. And just as a reminder, we looked at that just a minute ago and turned that on its edge. This right here is that main lobe, and then you got a second lobe right there. It's plotted coming up from there. So now we got a way to start looking at what the gain is at a takeoff angle in a graphical format. Those other things about the takeoff angles to different parts of the country, this starts throwing in what the percentage is of the time that a signal comes in at 7 degrees. This is going to be a long session.
Comes in at 7 degrees.
Yeah. Okay, is it appearing right now? I said, I apologize. I've never had this problem in any presentation yet. So it comes in at 7 degrees 10% of the time. At 20 degrees, it only comes in at 2% of the time. So what we're going to want to do is try to get that lobe of the antenna to cover the majority of time, the angles that are coming in the majority of the time. And that's what we have right here is we overlay these gain lobes over the takeoff angles. In this case, I'm using a takeoff angle screen, which shows South Carolina to Europe, and you can choose the different areas that are available out there. And this is over flat terrain at a 50-foot elevation. And the other thing I'll point out of here is there's something called a figure of merit. What Dean did is he trying to come up with a value that says, okay, you got a gain here at that particular takeoff angle, you got a gain here at that particular takeoff angle, and he's using kind of like calculus to figure out how well this particular curve does over the majority of the takeoff angles. And we'll start seeing how things don't work out in the next couple slides, hopefully, if this thing stays with me. Here's going to Asia from here, and you can see most of the takeoff angles going into Asia, like we said, from South Carolina, are extremely low angles. And I've got a figure of merit at 8.8 here for this one, but I got a figure of merit at 10 there. So that gives you a way to kind of do a comparative analysis as to how things are going for each one of your antenna comparisons. This is looking at two curves for a antenna at 30 foot versus 70 foot. Obviously, the lower gain, or the gain that occurs at the higher angles, is going to be the lower antenna. The blue is the 30 foot. Has a figure of merit of 5.4, but going up to 70 foot, you get a figure of merit of 9.9. So it's worthwhile in this case, obviously, going from a 30 to a 70-foot antenna. Again, we're looking at European takeoff angles. And you got to do that comparison for each one of the areas that you're going to, Asia, Japan, Africa, South America, to get the overall picture of what's going on. You don't, unless you just want to try to work one particular direction. A lot of people say that a higher antenna is better, and they'd love to have a 180-foot antenna. So I laid these three out, 50, 70, and 180 feet. And if you start looking at this, alrighty, so this lobe right here at 180 makes it so that if you look at it, sometimes that 70 degree, sometimes that 50 degree antenna just whoop the crap out of that one up there 180. In fact, the figure of merits for all three of these are pretty close. And if you go ahead and look at the next thing, this right here gives you a 20 dB gain just with a 70-foot antenna, and pretty much 50-foot antenna over something that's at 180 foot. That's one reason I don't give up being a little pistol station trying to go up against somebody with a big antenna. Now, if they've got stacks and things and cover all these angles, that's a different story. But I sometimes, and not all the time, but sometimes whip up on them boys with the big antennas, and that's one reason why right there. So don't give up. HFTA stacks, here's an example of it. This is a 70 and 140-foot stack from 20-meter antennas. I just threw the numbers in there. That's probably not optimal. But again, the two kind of overlap on these particular angles that come in from there. The 70 and 141 kind of overlap quite a bit, so you can pick and choose. And if you run up at the same time, you get an extra couple dB. And that's why people like stacks, because you can cover this whole direction. And oftentimes, one or the other antenna beats the. All righty, so we left off talking about the two and how they add together a little bit to give you a couple extra dB. And that's basically how a stack will work as well. Here's one of the ones, if I was considering putting up a 70-foot tower, I decided I was going to do a 35 and 70-foot antenna and how that compared. And it did make a difference, 11.7 figure of merit compared to 9.2 and 9.3 for the others. But if you notice, for the US, the lower antenna, 50 foot, actually does just as good, or 30, even one at 35 foot did just as good as one at 70 foot. So you don't necessarily need one if you're going to, a high antenna, if you're going to be doing a domestic contest. That was kind of interesting to me. I've heard of people who did stacks and put them up and they didn't work worth a darn and they couldn't understand it. Well, they fed them out of phase. And when they did that, they ended up changing the lobe pattern. And when they started running them like that, obviously it made it much worse. So that was kind of interesting too, to have HFTA show you that. The thing about HFTA, which really makes it useful besides those plots, is that the terrain around you has a direct effect on it. Your antenna signal sends stuff off and bounces off the ionosphere, but it also sends it down here to the earth and sends it up. And then these things interact up there in the air and it changes your antenna signal a bit. And one thing that works on that is I found this picture kind of interesting. Some waves coming along in this direction, but notice when they hit a point, they change direction and it actually causes a deflection or a thing in a different angle. And that actually happens with the terrain and a radio signal just as well. It hits a high point and starts going off in different directions. And Dean Straw's whole point about HFTA was to figure out how do all these little terrain effects begin to affect the signal going off in the air? Because these things come down here and they add up, going directly there. You also get the ones coming down here that add up, back and forth, and trying to figure all that stuff out. It's quite the task that he went through. This is a layout of the terrain going from N4XL to Europe. And this looks kind of like I've got a mountain here, but you need to keep in perspective, this is going from 580 foot to 630 foot. So that's only about 55 feet going in there. And that's over a 3,000 foot distance. So there isn't any mountains or anything around me. That's very compressed scales. But this shows where my antenna is and how it goes off at the different angles. And you can get these terrain profiles from a couple different sources, direct from the USGS. If you go microdem, there's some information in there how to get them. The TU, Kilo 6 Tango Uniform, has a good website, and all you do is put in your latitude and longitude of your antenna to 6 places, and he'll generate the terrain profiles for you and send it to you for free. He does have some more advanced features that he charges for on a yearly basis, but you can get these terrain profiles for free from him, and he'll email them to you. So that was to Europe. And this one, hold off here for a couple of seconds, shows my terrain to South America. Much more sloping downwards, and I actually do have better antenna performance to South America than I do into Europe. And I come up with these at a 360 degree around the location QTH here, but I only did it. I chose the ones towards the main directions like 45 and 320 to get to Japan and South America and analyze those. When you start plugging in the actual terrain into it, this flat, nice curved flat profile goes away. And all those bumps and refractions and everything actually gives me, going to Europe with an antenna at 50 foot, quite a substantial increased gain over a flat terrain profile. I was pleasantly surprised to find out that I was in favored territory going in this direction. By the way, that says NS4T. That used to be my old call. I changed it. So when you start plugging in the actual terrain profiles, you see that things start changing. And because this is here over that particular thing, you notice that my figure of merit got much better over the consideration of the actual terrain than it does just over the flat. So I was glad to see that. Looking at South America, I've got even a better figure of merit, about a 12.8 over this particular case. So that worked out well for me too. Then I started asking myself, is it better to put an antenna at 50 or 70 foot? And when I started looking at Europe, if you're looking at the red and the green here, you can see the figure of merit's pretty close. Yeah, the 70 foot has an advantage over several different things. But again, I'm not looking, I've got a tri-bander, not monobanders. So I'm going to have to choose an antenna, which gives me the best compromise for 10, 15, and 20 meters. And by the way, this worked in 40 and 80 if you have horizontal antennas too. HFTA only worked with horizontal antennas. So when I started looking at this, I said, well, the 70 foot's a little bit better. Not significantly, but it is a little bit better. When I started looking at how it compared to the US, they're almost identical. So I don't gain much if I want to focus on domestic contests by going from 50 to 70 foot, and I gain very little going to 70 foot going to Europe. When I changed frequencies from 20 meters to 10 meters, I actually found that I have a figure of merit much better going to Europe on 10 meters at 50 foot than I do at 70. So that again, lets you know you need to analyze each one of your frequencies that you're talking about in the directions of your interest, and then get the overall big picture as to whether it's better for you or not. As I ran through everything, I decided that basically a 50-foot antenna was just as good as a 70-foot antenna for me at this location. And it wasn't until I got a tower up to 90 foot that I actually began to see an improvement with my. So here we got again, Europe to N4XL to the United States at 50 or 70. Figure merit says that they're about equal, so I don't gain anything by having my antenna 70 foot over 50 foot really to speak of, because so many of the US takeoff angle and arrival angles are in the higher upper range. 50 foot's just as good as a 70 foot for a domestic and contest. Going to Europe at 50 or 70 foot on 10 meters again, actually the 10, because of these lobes that happen on the one that's at 70 foot, the one that's at 50 foot, a little bit, the lobes are much broader and wider. I end up getting a figure of merit because of the gains that occur at these other angles is much better than the ones that occur at 70 foot, that I actually get a better performance out of the 10 meter antenna to Europe on 10 meters on a 70 foot antenna. So when I went through all these particular charts, I did it for 10, 15, and 20 meters. I did it to the main locations of Europe, to Japan, to South America, and I did it to Africa, although there aren't that many stations over there. I focused on the first three, and I printed out charts for 10, 15, and 20 at various heights, 50, 70 foot, even at 35 foot, just for the heck of it. I laid them out on a table and I looked at them all and I compared all the figure of merits. What I found out when I looked at every one of those particular systems is I get maybe 5–10% improvement going to 70 foot than I do over a 50-foot antenna. And in fact, as I mentioned, I'd have to go up to 90 foot to really start seeing a significant improvement, making it worthwhile. So since I didn't get that much of an improvement over 70 foot over 50 foot, I just stuck with a 50-foot tower. They're much cheaper. I have less trouble trying to maintain a 50 foot over a 70-foot tower. And I get the same performance basically out of it. So that was the decision process I come up with. Now, again, if you've got dipoles, wires, or whatnot, as long as they're horizontal polarized, you can use HFTA to figure that out as well. And if it's a multi-band dipolar G5RV or something, you can kind of do these comparisons as well, although there is a vertical component to a G5RV, so it might not be too accurate with the HFTA here. Using HFTA, pretty much like I said, I did compromise height based on all the three of them, examined the performance in several directions. And if you can put up more than one antenna, see what combination works best to cover most angles. I'm a big advocate of having more than one antenna for every single band that you contest on, and that's why, so you can cover those takeoff angles that the other one doesn't. Extremely important, I think, to improving it. This is the K6TU website. They have free terrain downloads, and they actually have VOA cap propagation predictions, which you can upload into their system, your terrain profiles, and it'll work to give you actual accurate VOA cap projections out of the data that comes from the HFTA calculations that's done on K6TU.net. They also have that program Microdem. You can do this and that and figure out how to get your terrain data, but that's very complicated, and I don't advise that. If you need to, look in the antenna compendium book. I think it's either 7 or 8. I don't remember which one it's in anymore. I talked about how to do that in there. If you read the notes that N6BV has out there about HFTA, he says, don't fiddle around worrying so much about 1 or 2 dB here or there, because his calculations are only accurate to 3 dB. So if you're off by a couple dB, don't worry about it. Also, I laid this out a couple times just to prove it. I put in my antenna at 120 feet, and I also ran a program at 119 and 121 feet, only 1 foot difference, and found a few places where there was a 3 or 4 dB difference in the results that were there. And Dean says, verify your results by plotting those 3 points and throw out if one doesn't agree with the other 2. And that's in fact exactly what I've seen. So don't just do it once you get your decision process made. Go ahead and run it at a couple of different heights and make sure that the height you've got is accurate for the prediction program. Again, this operates only horizontal polarization. The Aggies and quads are good for that. And stacked antennas, if you move them close to a half wavelength, you get inaccurate results. So we need to be at least a half wavelength apart when you're doing stack analysis. And it doesn't take into account man-made structures like water towers or buildings, or in my case, a couple metal carports that are out there. Just going to kind of live with that as that falls out. Dean, when I was talking with him and on the internet, made a very big point about this particular concept. He says, these elevation angles were computed for all times over an 11-year solar cycle, when each band is actually open. The degree which the antenna chosen for particular terrain cover all those angles. And he says the more effective will be those antennas terrain for all periods of the solar cycle. So in other words, he recommends strongly that you don't try to pick and choose how high to have your antenna at one particular time in the solar cycle. He says your best overall performance over that 11-year period is going to be done by running the analysis we just talked about and coming up with your best antenna for that overall picture, rather than try to set something up for just 1 or 2 particular cases. He stressed that pretty strongly. He also, I've been talking about that figure of merit, but he puts in it's only a snapshot of a complex situation, and it's not 100% reliable. Again, you've got that height difference causes some inaccuracies in the calculations. The figure of merit has evidently some fudge factors in it too, but I found that to be a very good metric, if you will, to determine which antenna is better. And then you can kind of verify that by looking at the picture yourself overall. And if there's a real big difference, then obviously it's important. If it starts getting close, it's probably not that critical to it. But the figure of merit over the entire range of possible elevation angles, low angles are especially important during periods of low solar activity, as you would expect, because those are the only possible modes of propagation. They have a type of data out there called SRTM, which was done by the space shuttle. And they shot a radar down from up there in space and mapped everything. And when they did that, it hit the top of the trees. So it didn't really recognize what the ground terrain was underneath it. And the K6TU website doesn't use this type of data for stuff in the US, but it does use it for stations outside of the United States. They call it a different thing now, but it basically has the same limitations that this does, as far as I understand. And it is not the higher resolution terrain profiles. So HFTA is just not going to be as accurate if you're trying to run this outside of the United States, unless you can come up with a much more accurate terrain profile data than what's available through K6TU. I hate to say that, but that's the case. On dipoles, we know that dipoles go 2 different directions, the broadside to the dipole. This is only written to show the terrain profile and the gain in one direction. So if you got a dipole, you got to run it both directions broadside to your antenna to get the big picture as to what's going on. Dan, AC6LA, had a post in QRZ.com last month. He talked about going to the next level. Microsoft Excel created a 360-degree azimuth terrain plots in EasyNet to cover comprehensive views. And he's got a link to a couple things in there. I suggest you go back to it and take a look at it if you're interested. But this is some of the data that he projected from it. So you can get a three-dimensional plot of what's going around instead of the one-dimensional application. He ran this in through an EasyNet program, and that gives you a big picture of what the gain is in the different directions, the actual gain based on the terrain in your area in all 360 degrees, instead of doing it in just the limited amount that I did just a minute ago. And then he also was able to generate 3D, both what is flat ground and what it is based upon the actual ground around his location. By the way, Larry, I haven't had a glitch from this since I haven't moved my laser pointer up in the screen. So that could be part of what the issue is. I'll focus that a little bit later. And the thing about these three-dimensional plots and why I'm not overly excited about them personally is the data comes right out of the HFTA program pretty much, and that's where the calculations come from. And I've already done all those calculations and made my decision, but if you want to get a big picture feel of what's going around your location, that's a good way to take a look at it and figure out where you would have your best gains and get an overall snapshot without going through the tedious procedure I did of printing them out in different directions and then compare them one by one by one. So in summary, how well an antenna plays depends on takeoff angle to the target area, the antenna height, and the local terrain. Lower is sometimes better, and more than one antenna per band will definitely help your overall signal presence. Design your antenna to cover all angles. If you can't, choose what's most important to you. Do you want to work US? Do you want to work domestic? No antenna will do everything. When someone asks what antenna they should put up, I always answer them with a question. What is it you want to do most? Do you want to do US? Do you want to work DX? Do you look into Europe? Whatever the case may be. So figure out what you want to do and then start tackling the HFTA part of it. Are there any questions?
I can tell you, yes, there are questions. I just don't know whether anybody's asking them. So the floor is open to anyone who has a question of Kevan about any of this stuff.
I apologize for poor performance of the presentation.
This is Rob K6KM. I have a question. You mentioned this is only for horizontally polarized antennas. Is there anything out there for vertically polarized?
I have not found anything for that. Wish I did, but I've looked and I didn't find anything. Does anybody else know anything? Dean said he didn't have any intentions of developing a program for that either.
Okay, thank you.
More questions?
Kevin, sorry, this is Bob Tuttle, N8YXR. It's not really a question, but a comment I'd like to make. Looking at improvements at our station, I've seen not quite the same situation, but what I've seen is that kind of similar to your conclusion of higher isn't always better. So for instance, in quite a few locations in Michigan, because we're so flat actually, you don't get much. You get a pretty good boost from 40 to 70 foot, but much past there, depending upon what band you are and what location, but exactly where you are, you don't get much bang for your dB buck much above 70, it looks like, in many locations. Now, I haven't done like every place in Michigan, no UP, but I think you hit it on that it's not necessarily higher is better. You really have to take the local terrain in, and this program's pretty pretty great for doing that.
Is, and with both K3LR and W3LPL, for example, you guys have probably read before, one of their secret weapons is to put a 10-meter antenna or something down at 35 feet for filling in some of them takeoff angles that their higher antennas just won't get. So that's another comment. Since we got a minute or two, there don't appear to be a lot of questions. I'll take just a second or two. And this is actually the HFTA program. It's pretty simple to use. You put in a frequency, like, can you see this? Are you seeing my screen?
Yes, sir.
Okay. Just type in a frequency like 14.2. There are some options over here, like units, feet, meters, what type of soil do you want to have, etc. I already plugged that in. I chose a terrain profile, in this case of at 45 degrees, and I chose a 3-element antenna, but you can change all that just by clicking on these things. You can choose the height, in this case 50 foot, or I can stacks by putting them on the inside of there. I choose the different terrain angle. I had this set up so I can get to them quickly just by clicking there. Let's say I'm looking, again, let's look at 40 degrees. And then you just hit compute and this come up there, but there's your actual HFTA program that comes into play. So if I close this out, and let's say I wanted to see what the same thing looked like if I move this up to, that's 40 degrees, I'm keeping my 3-element antenna, and I put this one up at say 120 feet and put OK and just hit compute. Now I've got a comparison between the two. So the program is really simple to use. You can put the same antenna height, the 50 foot going to Europe and overlay, and the second one going to South America at the same time. That's how you add stacks. It's simple to play with and work out. And you can print these out to a PDF file or a picture file and then print them out and lay them out as well.
Kevin, there is one question in the chat room,
Okay.
and that is interested to understand the sequence of steps to generate these for my own station. Is there a tutorial on the process online?
I can't answer that directly because it's been 10 years since I actually did this. What I highly suggest is go to the K6TU website, and I'm pretty certain he's got directions to how to do it. And whoever the person is, if you email me, I'm on qrz.com, or my email is knason00@gmail.com. N4XL, you can look me up. I'll be happy to get with you and walk you through how to do it.
And then as a follow-on question from him, this is Jeff. He says, is HFTA available as a free download?
No, I haven't found it out there anywhere. It's part of the ARL antenna handbook group. I think they used to be available, but Dean's going through the ARL now on that one.
And then another question is, how accurate is HFTA, the HFTA program for 50 megahertz?
I don't think he goes up that high. I don't remember. Anybody else know? I wrote that down, and if you would get that guy's information to me, shoot an email.
All righty, that's all we have in the chat room at the moment.
While somebody else is getting ready to ask a meaningful question, I have this one, Kevin. I don't have and never have had, even though I've used them, stacked Yagis on a tower. So let's just suppose that I've done some sort of, John N4XL has said with regard to that question that yes, it does do 6 meters. Okay, so I want to have those 2 Yagis on that tower, and I've done computations and gotten advice on how much distance to put between those 2 antennas so that they will be, in theory, most effective. And listening to you, there may be some variables like most effective depending upon what part of the world you're wanting to focus upon and what your terrain is like. So is it safe to assume that HFTA, while you can look at a stack that and you may have explained this, that you're going to look at the comparative performance of those two Yagis operating when selected in a stacked arrangement, that you're going to be able to look at those two antennas individually and compare their results?
Yes. All right. You're seeing my screen right here, right? While you
Yes,
were
sir.
talking, what I did is I put up 3 different signals or 3 different stations, all going to Europe from here at an angle of 40 degrees. They're all 3-element Yagis. And the first one is a stack at 50 and 100 feet. The second one is at 50 and a third one is at 100. I click here. This is how it's done. 3-element, typed in height 1 at 50 and height 2 at 100. You can go up to 4 stacks. Then I put the second antenna just at 50, which is what that 50 and 100 is, and the second one at 100. And I hit OK. So I've got essentially, this is the stack. That's the one antenna at 50 foot. That's the second antenna at 100 foot. And I hit compute. The blue is the stack. The red is the 50-foot one, and the green is the 100-foot one. Does it that quick?
Interesting. So here's what I would be interested in knowing. Somebody who does use stacks, and I know like Ralph and Craig, I don't know who all else has stacked antennas. So what can you learn from this? I mean, are your 2 Yagis in the correct place?
Okay.
Oh, let's see. Ralph
Take this
says
picture as you see it.
Yes, sir.
I'm listening. Take this, look basically at how this blue line comes in from there. And this is for one at 50 and 100. Now I'm going to close this and I'm going to change this and move that up to, I don't know, let's say this is a 70. No, let's keep that the same. 50. And let's move our second 20-meter Yagi, and this is way off the wall, to 140 feet. And I'll make that be 140 feet. So now we're comparing everything. And I hit compute. See how it changes it? So you can try to figure out what is your optimal spacing to give you the best combination of gain between the 50 and the 140 foot one as you play around with your different heights so that you get the best optimal type of phasing between them and the strongest signal that comes out. I think that's what you were talking about, correct?
I can
yes.
make some comments about this. This is Craig K9CT.
Please. Yes, sir.
I have
We'll listen to you any day.
well, no, I find this interesting. I did this when I was designing my station, and actually I talked to Dean Straw and got essentially the same information, and I have nothing new to offer here other than actual experience. And I find always having 2 antennas on is the best way. It's in a stack. So when now I have to tell you, there's exceptions. You might find that one of the antennas is like the lower antenna might be the antenna for a DX station. But you'd never know that if you don't have multiple antennas. So if you're in a pileup and you're not getting through, you need to switch quickly through all of the different antennas and find out if there was a better arrival angle, or maybe you just don't have propagation. But I find that the top 2 antennas always seem to work really well on early openings. And then I use the bottom 2 antennas. And if there's any long openings, like in the middle of last week's contest where it was over the pole, we could work the VUs and the 8Q. They were coming in quite well. And I was using the top antenna. And I've had friends that compare RBNs while I'm operating. And there's a significant improvement that you can actually see. I mean, they tell me many dB difference, 10 to 20 dB difference sometimes with the stacks at high elevations. N0AX sent me a note earlier today about him being on 15 meters and missing some stuff that I'd worked. And of course, his antennas aren't as tall as mine are, or as high. And you could say that that was probably, I was maybe just significantly louder, and the station called me because I wasn't in a pilot to work the stations, they just called me. So, and I found also that for domestic contests, a lot of times the stacks, you really have to have a lot of other antennas. And I know that Larry talked about that. So I use a stack match, and I use a lot of combinations. And of course, I'm in the middle of the country, so it's a mess here. Everybody's coming in from every different direction. But I have found that I needed to add lower antennas to be effective domestically. And so this is really a great tool. And of course, the more antennas you can put up and have is great. But I also totally understand what Larry was talking about. What's the best antenna for generally what it is I want to do? And it comes back to that. So if you have limited real estate or a tower, what can I do to be most effective? And this is a really great tool. I highly recommend it.
Okay, now Craig, I have a question for you. You have a lot of towers, so I don't know that you do this or could do it, but it'd be interesting. Let's suppose you, now on your towers, when you're talking about the top two or the bottom two, that's when you have a triple stack.
Right.
You're not, right?
Right. I have, on 20, I have 5 over 5 over 5, 6 over 6 over 6 on 15, and 8 over 8 over 8 on.
What are your heights on 20?
The highest one is about 190 feet. And the other, well, I can't tell you right now. I frankly don't remember.
Sorry,
I can tell you for
spot.
sure because it's a 190-foot tower, and I got about a 4-foot rotating base underneath it. But it's a real low angle.
Yeah. While Kevin's working, my question is just out of interest. Suppose you have a one Yagi at 190 feet, and below that, let's say at 70 feet, you have another Yagi, and then you have one at 35 feet. So what would it be like if you took the Yagi at 190 feet that's on one tower, and the exact same antenna that's at 70 feet on tower A, but it's on tower B and it's pointed in the same direction? Does it make any sense that there would be any similarity in running the top antenna on tower A and the middle antenna on tower B on the same band, pointed in the same direction, as you would get, or there has to be some effect that you get from that, from the stacking?
We actually, I have a lot of physical isolation between my antennas, so in wavelengths. And I did that on purpose to avoid the mutual coupling that you're talking about. And in fact, if you ever look at rotating antennas on the same tower, because people will do that, like NM5M, I believe is correct. No, that's not correct. NR5M has 33 rotators. So he's got 33 antennas on ring rotors, and they're stacks. And before I built my station, I went down there. And if you ever try to splay antennas, you end up with terrible patterns. And that's exactly what he ran into. Plus he had 33 rotators to fix. So I decided to go with just stacks that are fixed and rotate the tower. But I have other Yagis that are on they're multiplier antennas, and they're on the same band, but they're fixed at 70 and 140 feet. And they're on separate rings. And so there's very little coupling, and there's enough isolation between bands. In fact, I'm in a project right now. I just bought 2 more Yagis for 10 and 15. And to use for in-band operation. So you can tell there's not a lot of coupling because we're able to operate in band without tearing up a radio. So,
Yeah, but you're also using those good flex radios too.
yeah, well, look, you know, there's some really good radios out there that can handle it. But, you know, one of the charts that you really need to keep in mind is you gotta, if you're using 63 dBm, which is a 1500 watt amplifier, 0 dBm is a lot of IMD. So you got to have 63 dB of isolation between your transmitted signal and your receiver, so you don't end up with all this crap all over your receiver, regardless of the radio. There's just a lot of things to think about. This is a multivariable problem if you're designing a contest station, but it's really a lot of fun. And to see the results of it. And you know, Larry, you know, you've opened a can of worms here to a lot of interesting things. And that's why I attended tonight, because I just love hearing what people have to say about these things.
I'm the world's most curious person. I wonder about other things too. So Kevin and Craig, especially, maybe others, to what extent in the scope of this conversation we've had tonight, do other things come into play, like feed line loss, just the other things that are in line between your radio and the antenna? I mean, we can look at the theory of this HFTA, but then the real world, I suppose, kicks in. You're working to make sure that you minimize any of those losses and
right. When I designed
strengths.
my system, I designed it to have less than half a dB loss between any tower or any antenna to my radio. And so I have a lot of 1 5/8. I have 14,000 feet of it buried under the ground. So that's stuff you got to think about. But if you look at my layout, the 10-meter tower and the UHF is no more than 30 feet from the shack, and the 160 is 1,100 feet away. So, you know, you can just see how you want to have that isolation, and you can have the loss, because you could probably run RG8 out there and it wouldn't make a bit of difference, although I wouldn't do that.
Okay,
Larry, if you remember in my vertical thing, I talked about an antenna system, and obviously my single tower at 50 foot is compared to crash stations definitely out oranges. And I talked about making compromises and choices based on the resources available, but trying to understand what those compromises were. In other words, not running hard line. You get the 100, the loss in the coax, but then if you don't match it well at the other end, you get the increased loss in the coax due to the high SWR. Those are all compromises that come into play. Those do not affect these terrain profiles or the gain that comes off the antenna. They're just a part of the overall antenna system performance. And also, I'll add another thing in, Craig, you might find it interesting. We're operating an NQ4i. Larry, Jim, and I were both on 40 meters running 1,500 watts with his 40-meter stack, and me with a 4-element 135 feet. And we actually found ourselves on the same frequency calling at the same time. Yep. Stations in Asia, for example, and the Orion 2s that he modified didn't blow them out.
Yep. Yep. It's funny how that works. I'll be running SO2R this weekend on 160. Think about that.
That kind of scared me. Okay, so Kevin, with your permission, I'd like to ask Craig a question, because I don't know how many other people who are in this conversation have done this. But Craig, you've been on a lot of de-expeditions. So obviously, given the limitations of the geography where you are, you have to make decisions about where you put the antennas and why you put the antennas. I mean, you paid a lot of money and spent a lot of time to go to somewhere. So what do you use any of the analysis like this? I mean, do you have access to, what do you do?
Well, we plan it in advance. You know, we know the geography before we go, and like, you know, there's a lot of cases that you're restricted and you just have no choice. Palmyra Island, for instance, was terrible, but you know, in terms of being restricted, as we had to have verticals and blah blah blah. And so, but you know, when we went to Wake Island, we had physically separated sites on purpose. So usually we'll have phone and CW separated. You know, if you remember when we went to Swains Island, 2 separate sites about a quarter mile apart. We went to Amsterdam Island. That was probably 2 miles, 3 miles apart. And so we really try to think of that stuff. When we were at Pitcairn last year, we had 2 physical sites. But you know, you're operating very close proximity, even when you're within a site, and you can overload radios. So we use filters, but we also use high power filters. And high power filters are really good because most amplifiers have a really bad second and third harmonic all by themselves, especially tubes. And so high power filters, you know, you're going to get maybe 50 dB of isolation if you get the good ones, you know, the LBS or 403As or VA6AMs. Those type of filters are really good high power filters. So, but the answer is yes. Every single place that we go, we sit down, we lay it all out, talk about it, because you don't want to blow up any radios, and you don't want people angry with each other. It's you know, I'm sure everybody's been to a field day where people get mad at each other, and it's because they just everybody brings their own radio, throws up antennas, and then all heck breaks loose. So, you know, it's the same physics. You know, everything has to be thought about.
Wow, that's wonderful. Kevin, thank you for allowing me to ask those questions.
I'd love to hear Craig talk anytime. Larry, there's a book out there, how to manage station interference. I forget who it is, Kierkegaard? I think he puts that out. Craig, you probably know that one. You might find that interesting.
W2VJN that wrote it.
I can't tell you what kind of a novice I feel like. I'm only 72 years old. I guess it's about time to start learning, isn't it?
We're all learning every day. It's fun. Yeah, there's Jeff just put it up there. George Cuts George. I met him. He lives out like Portland or Seattle area, somewhere in there in the Northwest. And the Viroplex people were selling the book, but I think it might be out of print. If you can get one, it's a really great book. It's you'll read every word in it. There's a chart I actually use in my presentations. I steal it right from him because it's just excellent.
And I noticed that Jeff is a thief. He borrowed a book.
Yeah, it is very good. It's
I wonder if he'd ever checked the book back into the library from which he borrowed it.
Yeah.
Oh, me. Well, Kevin, I know you're in the Eastern time zone and have to be sensitive to the fact that it's 9:25 and you want to be ready to watch the news when it comes on. So do you have some more to give us? And we'll
no, I'm a little upset that the whole time we've been talking here at the end, nothing's dropped out. It dropped out through my presentation, but no, that's pretty much it. I'm glad to have the opportunity, and I apologize again for dropping out. Everything's been fine.
Something which you have no control. Well, I'm going to end the recording right here. That doesn't mean we end. Last time I just ended the meeting. I didn't intend to do that. So I'm just going to say this in closing. I want to thank everyone who's come tonight. We close this recording. We will have more. When we post this to YouTube, I suspect we'll do a little bit of editing, but we will be adding some more information to it. So if you go to the YouTube and you watch the video, then later on come back and see if we've added some more stuff. We may get Kevin to send us his PowerPoint file, so we may put that there as a file that you can grab from a Google Drive or something that you could actually look at. Kevin is a very generous person, so especially under tonight's conditions. And thank all of you for hanging in here with us. We had upwards of 50 people with us tonight, and everyone who participates counts. So we will have more, and we'll be calling on some of you to help us. While this is the Deep Dixie Contest Club, I hope we're doing a good job of putting the message across that the doors are wide open, and so this is a worldwide ham community for all of us. We just like to be the ones who are having the party. And those of you who may not know that Jim Rosser, AA5W, who's a co-host to this, is our vice president of this club, and great operator, and also John McVeigh, K4AFE. So with that, I'll say goodbye for now. We look forward to seeing more of you next time. So for right now, I'll just end the recording.